Hi students, in this video we are discussing about redox reactions. Okay, in this redox reactions we have what are the concepts we have to cover. So what is the redox reactions? Oxidation, reduction, and next one, oxidation state, how to find out oxidation state, and types of redox reactions, and oxidizing agent, reducing agent, balancing redox reactions, finding N factor, and doing redox titrations. So these concepts we have to cover in this one. Here basically oxidation and reduction case. Here oxidation will be involve loss of electrons, addition of oxygen or electronegative atom, removal of hydrogen or electropositive atom, or increase in oxidation state. This comes under oxidation. And reduction means gain of electrons, addition of hydrogen or electropositive atom, removal of oxygen or electronegative atom, decrease in oxidation state. Decrease in oxidation state will be comes under reduction. If both oxidation and reductions occur simultaneously, then we are calling as a redox reaction. Redox reaction. Okay. So these are basic definitions for oxidation, reduction, and redox reactions. Okay. So this part will be this one. Next one, we have to find oxidation state. What are the rules will be there to find the oxidation state, and we'll go through one by one. First one. Here, first rule: any element in free state or uncombined state. What is the state? Free state or uncombined state. Free state or uncombined state, the oxidation state will be of element will be 0. Okay, suppose I am taking P4, S8, Br2, H2, Fe. So in this case, what is the oxidation state? Phosphorus here 0, sulfur here 0, bromine 0, hydrogen 0, and iron 0. Okay, so uncombined state or free state is there, then its oxidation state of element will be 0. That is the first rule. Okay, next we are coming to the ions. We are coming to the ions. Ions case, if you are taking monoatomic ions. Okay, in this case, the oxidation state equal to charge present on ion. Oxidation state equal to charge present on ion. Suppose we have Ca2 plus, then oxidation state of calcium will be plus, and O2 minus, then oxidation state of oxygen will be minus, like that. So monoatomic ions, the charge present on ion will be equal to the oxidation state. Okay, and sum of oxidation states equal to 0 for neutral molecules. Sum of the oxidation states will be equal to 0 or equal to charge for polyatomic ions. Okay, if you are taking water, okay, so 2 into oxidation state of hydrogen, okay, and 1 into oxidation state of oxygen will be equal to 0. Okay, so here like sulfate ion we are taking 1 into oxidation state of sulfur plus 4 into oxidation state of oxygen equal to minus 2. So like that we can find sum of oxidation state will be equal to 0 for neutral molecules and charge present on polyatomic ion, that is for charged particles. Okay, and we are taking first group element. First group elements for you have lithium, sodium, potassium, rubidium, and cesium. This will be shows always +1 in compounds. Okay, always shows +1 in compounds, and second group elements beryllium and magnesium, calcium, strontium, barium shows +2 in compound. This is always shows +1 +2 oxidation state in compounds. Okay, and fluorine will be more electronegative atom, so it will be shows -1 in its compounds. It shows -1 oxidation state in its compounds. Okay, and next, going next. Oxygen generally have -2 oxidation state, but in some cases it will be different. It have peroxides we are using, then it will be have -1. Superoxides case, it will be -1/2. Like you have XeP2, O2, PtF6 case, we have O2 plus ion will be there. In this one, +1/2 oxidation state will be there. And other than that, it shows positive oxidation state only with fluorine. O2F2 case, you will have +1 oxidation state. O2F2 case, you will have +2 oxidation state. So in this case, it will show us positive oxidation state when it is attached with a more electronegative atom. Next one, hydrogen generally shows minus. It is a generally shows +1, and but in metal hydrates, it shows -1 oxidation state. Okay, so metal hydrate normally you are doing normal hydrates where +1 oxidation state is there. You are doing electrolysis. It comes under cation. It will be go to the cathode. But metal hydrate, the ion will be have H-. It is anion. It will be moved to the anode. Okay. Example for metal ions, many we have lithium aluminum hydride, calcium hydride. Okay, like it will be there. Okay. Similarly, we have halogens. Halogens generally, other than except fluorine, it shows -1 oxidation state generally. But when they are combined with a more electronegative atoms, it will be shows with more electronegative atom. It will be shows +1, +3, +5, +7, etc. When they are attached to more electronegative atom, that will be shows a positive oxidation state. +1, +3, +5, +7, etc. Okay, so these are common oxidation state. Oxygen, hydrogen, X case. These are general, but some exceptions will be there when they are attached to more electronegative atoms. A few cases. Okay, so these are general rules will be there when you are finding the compounds. Okay, and if you have covalent compounds, covalent bonds is there. Okay, so covalent bonds will be there means how we can able to find covalent bonds. This covalent bond will be present between similar atoms like A attached to A. In this case, this contribution will be 0 and this contribution also will be 0. So two similar atoms are attached to each other, then each contribution will be 0. But if A attached to B, let's consider B is more electronegative than A, electronegativity wise. So B is more electronegative, one bond will be have, so -1 this one, +1 you will get it. Suppose double bond is there, this will be get -2 and this will be get +2. Triple bond is there, then it will be have -3 and this will be have +3. Okay, so this is the covalent bonds will be present between similar atom, no contribution, but different atoms are there. Based on electronegativity, you have to give that, and based on number of double bonds. Okay, single bond, double bond, triple bond. Based on that, you have to decide oxidation state. This is a covalent bond related. If coordinate covalent bond is there, coordinate covalent bond. Coordinate covalent bond case, you have same B is more electronegative than A. Let's consider same thing. In that case, what happens? A donating electrons to B or B donating electrons to A. Okay, so maybe coordinated bond will be A to B or B to E. So we know that this is a less electronegative, this is a more electronegative. So less to more means contribution, this more will be -2, less will be +2. But if it is more to less is going on, then it will be contribution will be 0 and 0. Okay, this is a special case in a covalent bond case. Okay, so by using these concepts, we can able to find the oxidation states. And other than that, some key points you have to keep in mind. Okay, what is the key point? The maximum oxidation state of any element equal to the maximum oxidation state will be equal to the number of valence electrons. Okay, suppose if 6 valence electrons, then it maximum plus 6 only it will be possible. And like chromium, sulfur will have maximum oxidation state plus 6 only. If any cases chromium or sulfur you are getting more than plus 6 oxidation state, means that is the some peroxy bonds will be involved. So we have to consider peroxy bonds, and the answer mostly it will be have plus 6. Okay, and these are some compounds we have seen. We can check some examples. Simple example first I am giving. MnO4 minus. Okay, it is anion. So this you are finding is x plus 4 into minus 2 is equal to minus 1. X will be comes under what? Plus 7. I am taking one cation NH4 plus. Okay, so this is you are finding x plus 4 into minus 1 is equal to plus 1. So hydrogen will be have plus 1 oxidation state. So x is equal to minus 3. Okay, and we are checking another neutral molecule. Okay, if we take any neutral molecule, H2SO4 and then sulfur, and finding 2 into plus 1 plus x plus 4 into minus 2 is equal to 0. So x will become plus 6. Okay, these are general ways of finding oxidation state. If it is already you have any element like iodine is there, then its oxidation state will be 0. If it is Ca Mg2 plus is there, means oxidation state will be plus 2. Okay, so like that we will find. These are simple general examples we have. Other than that, we will see some different examples. What are the different examples? Like Ca or Cl2. Okay, so in this molecule you have calcium attached with one chlorine, one OC. Okay, it directly attached. It is attached to metal, so it will be have minus 1. But it is attached to non-metal and more electronegative one, so it will be have plus 1 oxidation state. And second one, ammonium nitrate NH4 NO3. Here two nitrogens are there, but you can see two different oxidation state will be present. Here minus 3 and here plus oxidation states. Okay, and similarly if you take some other examples where peroxy bonds are involved. Peroxy bonds will be involved. Okay, so H2, S2, O8, Marshall acid, and H2, SO5, Caro acid, S3, PO5. Okay, and CrO5. These are some peroxy acids will be there. In this case, generally if you find oxidation state, you will get the X value. This is plus 2 minus 16, so plus 14 by 2 means plus 7 you will get. But it is not possible, so you can think peroxy bond will be present. And sulfur attached with the one peroxy bond, S double bond. So in this case, what do you have? Minus 2, minus 2, minus 1. Okay, this one bond, so this is the X. X will becomes plus 6. Okay, same way here, also peroxy bond will be there. O, OH and OH. Minus 1, minus 2, minus 2, minus 1. This is the X. X minus 6 is equal to 0, X is equal to plus 6. Here also you will get the plus 1. Here CrO5 is double bond, butterfly structure it has. These are minus 1, minus 1, minus 1, minus 1, minus 2. So x is equal to plus 6. Normally you are finding it is a plus 10 will be from, it will be not possible structure. Okay, these are peroxy acid case, S2, martial acid, and caro acid, and CrO5, S3PO5. These compounds, important peroxy acid. Next one, you are seeing now some peroxy acids and some mixed oxides will be there. Some mixed oxides kind of thing will be there. So example for this one, Fe3O. General average oxidation state you will get it here plus 8 by 3, but it compound have FeO and Fe2 both. It has plus 2 oxidation state and also have plus 3 oxidation state will be present. Okay. So these are mixed oxides. If they are asking average oxidation state, you can take like that. Otherwise, you have to take individual oxidation states. Some have like this Fe 0.98 oxygen, 96 oxygen. In this case, if you are taking 0.986 x plus 1 into minus 2 is equal to 0, it is a neutral 1. So x is equal to, you will get 2 by 0.96, that is nothing but 200 by 96. So these are, we can find oxidations like this. So in this way we can able to find oxidation states. Okay, few exceptions will be there that you have to carry. Peroxy acid, bleaching powder, like we have discussed. That few exceptions we have to carry. Okay, and also we are taking organic compounds. Organic compounds, what we have like CS3, C double bond O, H. So in this case, hydrogen, carbon, hydrogen will be have more or less electronegative, so it will be single bond, so plus 1 contribution. Double bond, more electronegative, minus 2. Carbon, 0 contribution. This X plus 1 minus 2 equal to 0. X will be plus 1. Okay. If we are taking formaldehyde, SC double bond over H. So plus 1 minus X. So X will be 0. Okay, so organic compounds we have to do like this. And some compound like C2O3. Okay, C double bond, C double bond, C double bond. So here this contribution is minus 2, this contribution minus 2. And this is the X. From this side contribution is 0. This is the X. So for this molecule you will get the X minus 2 is equal to 0. X will be plus 2. This is also plus 2. And this one will be 0 oxidation state will become. Okay, so if you have plus 2, 0, plus 2, oxidation state will be present. So this is a fractional method finding oxidation state. Okay, next one. Next concept is what? Types of redox reactions. Okay, so in this case, you have addition reactions, you have decomposition reactions, and you have displacement reactions. And you have disproportionation reaction. Disproportionation. And finally, comproportionation. Reactions will be there. Addition reactions, decomposition, displacement, disproportionation, comproportionation. Addition reactions case, how when it will be comes under redox reaction, suppose addition means A plus B giving rise to C. Okay, so when this reaction comes under redox reaction, either A or B in elementary state, A or B in elementary state. So at least one of the reactants should be in elementary state, then it will be comes under redox reaction. Decomposition means some A compound decompose and give B plus. So all decomposition reactions are not redox reactions. Here also, when they are comes under redox reaction, at least one product must be in elementary state. So then only it is comes under redox reaction. Displacement case, it will be two types will be there. One is a metal displacement. Another is a non-metal displacement. Metal displacement means here x plus yz giving rise to x, z and y is coming up. This is a more reactive metal displaced or less reactive metal. Okay, that is a metal displacement reaction. This comes under redox reactions. Okay, example, if you are taking zinc iron sulfate, give zinc sulfate and you will get the iron. Reverse is not possible. Iron plus zinc sulfate, no reaction will be takes place because zinc is more reactive compared to iron, so no reaction will be takes place. Non-metal displacement means either hydrogen displacement or halogen displacement will becomes. Like you have H2O is there, we are reacting with Na, means what you will get NaOH plus water. Here hydrogen, one of the hydrogen is displaced. Okay, or you can take this fluorine, chlorine and bromine iodine. The reactivity order will be like this. Fluorine can displace chlorine, bromine, iodine. Like fluorine can displace any ion and it will be give the X2 and F minus ion will be getting. Okay, so these are metal displacement reactions. Disproportionation means same element undergoes oxidation as well as the reduction. One atom undergoes oxidation as well as the reduction. Example for this one, like Cl2 is converted into Cl minus, ClO3 minus. Okay, so here 0 minus 1 plus 5. This is reduction, this is oxidation. So same element undergoing oxidation as well as the reduction, that is comes under disproportionation reaction. Comproportionation means opposite to disproportionation reaction, like BrO3 minus plus Br minus giving rise to Br2. This reaction comes under comproportionation reaction. So briefly these are types of redox reactions. Okay. In exams what they will ask, which of the following is a redox reaction. Okay. So in that case, how you can decide? Basically you can check one basic point, either reactant side or product side, any element in free state is present. Okay, reactant side or product side, element in free state is there, then that will become under redox reaction. Suppose if it is given KClO3 giving rise to KCl plus O2. So here this is element in free state, so it is a redox reaction. So like that you can predict it. And if you're all there is no option such a way that having the free state, then you can go with the finding oxidation state. Find the oxidation state. Where is the change in oxidation state is there? You have to find. Based on you decide whether it is a redox reaction or not. Okay. So these points you can easily remember. That point you observe, then based on that you can give. And also one more, H2O is there. If it is oxygen is liberated, then it is acting as a reducing agent. No oxygen is coming, then it is acting as an oxidizing agent. That is also one important question, that in which of the following cases hydrogen peroxide acts as oxidizing agent means. Oxidizing agent means no oxygen is liberated. Reducing agent means oxygen will be liberated. That point you have to remember. So these are types of redox reaction: addition, decomposition, displacement reactions, disproportionation, comproportionation reactions. Okay. Right. Next, oxidizing agent and reducing agents. So that you have to be careful one thing. We know first group, second, 13, 14, main groups are having 15, 16, 17, 18. Okay. So in this case, the valency electrons will be present 1, 2, 3, 4, 5, 6, 7, 8, and maximum oxidation state possible +1, +2, +3, +4, and +5, +6, +7, +8. Minimum generally, other than exception, this will be 0. Here carbon will have minus oxidation state also. General case it will be 0. This will be -3, -2, -1, 0. So we know minimum and maximum oxidation state, then we can able to identify oxidizing agents and reducing agents. Whenever you have maximum oxidation state is there, then it acts as oxidizing agent only. Okay. Maximum oxidation state is there means act as oxidizing agent only because it cannot undergo oxidation further. Okay, only decrease in oxidation state will be possible. Decrease in oxidation state means reduction. Reduction, the substance which undergoes reduction, that is act as an oxidizing agent. So that is a 1. And minimum oxidation state, then it acts as a reducing agent only. And if we have in between oxidation state, then it acts as a reducing agent and oxidizing agent. Also, it may undergo disproportionation reaction. It may undergo positive. Okay. So, whenever maximum oxidation state, generally we have oxidizing agent means it will be undergoes reduction and cause oxidation. That's why it is called as an oxidizing agent. And reducing agent means it is undergoes oxidation and cause reduction. So that's why it is called as a reducing agent. So whenever maximum oxidation state is there, then it increasing is not possible, oxidation is not possible, only reduction is possible. So it will be act as only oxidizing agent. And minimum is there, decrease is not possible, so reduction is not possible, only possible oxidation. So it acts as a reducing agent. It in between oxidation state, it will be act as both. Example for this one, HNO3, H2SO4, KMNO4. This will be act as an oxidizing agents only, cannot act as a reducing agent only. Cl minus HCl is there, so here -1, minimum oxidation state, it can act as a reducing agent. Right. So in between oxidation state like HNO3, HNO2, S3, S3PO2. So in this case you have +3 oxidation state. Here you have a +1 oxidation state. So they have in between oxidation state is there. Nitrogen case minimum this comes under 15th, maximum +5, minimum -3. These are in between oxidation state. So it will act as a oxidizing agent, reducing agent, and this will also undergo a disproportionation reaction. Suppose example, if you take S3PO3, it will be converted to PH3 and S3PO4 on heating. So that is disproportionation reactions also takes place when have in between oxidation state. Okay. So this is the concept related to oxidizing agent and reducing agent. Okay. Next one, balancing redox reactions. Balancing redox reactions. Okay. Oxidation number method is best one. Oxidation number method we can use. In this case, what happens? 5 steps are involved. What are the 5 steps? First, we have to find valence atoms. Other than oxygen and hydrogen. That is the first step. And the second one, find oxidation state, total oxidation state, total oxidation state, then change in oxidation state, and make it equal. This is the second step. So most of the times you will get the maximum answer here itself. And third one, you have to balance charge with H plus ions in acidic medium and OH minus ions in basic medium. Okay. And finally, hydrogens you have to balance with water molecule. Okay. Finally, check oxygen atoms both sides. Then, if it is the reaction is balanced, then it will be both sides. It will be balanced. So that is the oxidation number method. Suppose we take one example. Suppose MnO4 minus plus C2O4 2 minus, giving rise to Mn2 plus and CO2. In acidic medium, this reaction is going on. So in this case, first, how many manganese are there? One manganese. So that is no problem we have. Carbons are 2, here 1. So first balance atom. So this step is completed. Next, when find oxidation state, manganese will be have plus 7. Here, if you find oxidation state, plus 3. Here, plus 2 and plus 4. Okay, oxidation state completed. Total oxidation state we have to find. How many atoms are there? 1. How many atoms are there? 2. So plus 6, 1 and here 2 plus 8. Now change in oxidation state. What is the change? Plus 7 to plus 2, 5. Plus 6 to plus 8. Okay. So change in oxidation state we found. We have to make it equal. So this is a 5, this is a 2. So 5 times, this is a 2 times. Now what you will get it? 2 MnO4 minus plus 5 C2O4 2 minus and 2 Mn2 plus and 10 CO2. Okay. Now we have to balance charge with the H plus ions because it is a acidic medium. Okay. So 2 into minus 1, minus 2 charge, 5 into minus 2. So total charge will be minus 2. This side 2 into plus 2 plus 4. This is no charge is there. So what is the difference? Minus 12 to plus 4. Okay. So minus 12 to 0, 0 to 4. So total 16. Okay, 16 H plus we have to add. Which side we have to add? This side or this side. Suppose we are adding this side, minus 12 plus 16 H plus. So minus 12 plus 16 means plus 4 plus 4. It will be balanced. So 16 H plus. Okay. This side we cannot add. Now hydrogen atoms we have to balance. Here how many hydrogen atoms? 16. This side nothing is there. So 8 water molecules you can add. So this fourth step completed. Now check that whether it is balanced or not. 2 4s are 8 and 5 4s are 20. So 28 oxygens are there. 20 plus 8. 28 oxygens will be there. So this reaction is balanced. Okay. And in this way we can balance easily. You have to keep these points in mind and do the process fastly. Then it will be, time will be not wasted. Okay, so first what we have done, one more time. First we have to balance the atoms other than hydrogen and oxygen. Then you have to find oxidation state, total oxidation state, change in oxidation state and make it equal. Balance charge with H plus ions in acidic medium, OH minus ions in basic medium. Hydrogens, next balance hydrogen atoms with water. Check oxygen atoms on both sides. Okay, so first we balanced the carbon atoms, then we found oxidation state, total oxidation state, change in oxidation state. From that we got one equation. Then after that balancing the charge and after that balancing hydrogen atoms. Okay, and suppose disproportionation reactions are there. How we can able to do this one? Suppose P4 is converted into PH3 and H2 PO2 minus. Okay, so this reaction is there. How we can able to do this one? Okay, so simple step, write 2 times and do the same process. Here 4 will be there, 4, here 4. So do the same steps. Okay, then finally add the phosphorus P4 together, reactants, then you will get the balanced equation. So that is the where you can handle the disproportionation reactions. Okay. And the next one, what we have, one more method is the ion electron method. Okay. So in this case, we divide the equation into two ways. One is the oxidation of reaction and reduction of reaction. So we have to divide equation two steps, two reactions. One is the oxidation related, one is the reduction related. So here also steps will be involved in each reaction case. In each reaction case, what we have to do, balance atoms other than oxygen and hydrogen. Next, oxygen you have to balance with water molecules, and hydrogen you have to balance with H plus ions, and the charge we have to balance with electrons. Then after this one, make equal electrons in both sides, both reactions, then add it. So these steps are involved. Generally steps will be more will become. Suppose if same reaction if you are taking MnO4 minus is converted into Mn2 plus, and the next one C2O4 minus converted into CO2. First, manganese balanced, so no problem. So 4 oxygens are there. Then what happens? You have to add 4 water molecules here and 8 H plus ions here. Okay. Now hydrogens are balanced. Oxygens 4 are there, 4 water molecules. Hydrogens 8 are there, 8 H plus ions here added. Charge this side plus 8 minus 1 plus 7. This side plus 2. So the difference is 5. So 5 electrons we have to add. So here positive charge is more. So we are adding electrons here. And here in this case, how we can able to do? In this case, here 2 atoms, 2. Okay. Now oxygen balanced, hydrogens are not required. So charge minus 2 to 0. So here how many electrons? 2 electrons. So we have to add this side because this side negative charge is less. So 2 electrons. So same way, first reaction. This is the first equation. This is the second equation. So first equation we have to multiply the 2. Then add to the second equation. We multiply with the 5. Then finally you will get the balanced equation. Is we got same MnO4 minus plus 5 C2O4 2 minus plus 16H plus giving rise to 2 Mn 2 plus and 10 CO2 10 H2. So this balanced equation again you will get it. Sometimes we require only half reaction they ask to balance, so that ion electron method also one time you have to go through it, then you will get the idea. So here divide the equation into 2 parts, oxidation of reaction, reduction of reaction. Okay. And here you no need to find oxidation state. Okay, that is the one advantage. Balance atoms other than oxygen and hydrogen. So manganese be balanced, same is there. And 4 oxygen means 4 water molecule you have to add other side. 8 hydrogens means 8 H plus add other side. Then balance the charge with the electrons. And here also do the same process. And the 2 reactions you have to add such a way that the electrons should be cancel each other. Okay. So this is the ion electron method. Okay. And finally, we have come to the N factor. Okay. So N factor case, how we can able to have N factor? N factor also called as the valency factor. Okay. So generally we can do 2 methods. Okay. So without balancing the atoms, without balancing atoms we can do, and with balancing atoms we can do. So without balancing atoms means how we can find valency factor or N factor. So change in oxidation state into number of atoms. Okay, here the valency factor how we can find? Total change in oxidation state by number of moles. So these two methods are there. Suppose like C2O4 2 minus is converted into CO2. Okay, I'm not balancing carbon atoms or oxygen atoms. Only I am finding basic oxidation state plus 3 converted into plus 4. Change is how much? 1. How many carbon atoms are involved? 2. So it is a 2 valency factor. Okay. Or you want to find here valency factor by balancing this, you have to write 2 CO2 and here 2 into plus 3 and 2 into plus 4. So here change will be 2. How many atoms? How many moles will be there? 1 mole. 2 by 1. So both cases you will get the same answer, but here we are not balancing atoms, we are balancing atoms and we are doing the process. Okay. And next case, generally you have to know that this KMNO4 related. It will be oxidizing agent in acidic medium, neutral or slightly basic medium, and a strong basic medium. In acidic medium, it will be converted into Mn2 plus, neutral medium MnO2, and in this case MnO4 2 minus. So what will be the valency factor will become? Here plus 7. So here valency factor will be 5. Here valency factor will be plus 7 to plus 4. So 3, and here valency factor will be 1. Okay. And K2Cr2O7 case, valency factor will be 6. Okay. Because it is only give Cr3 plus ions. Okay. So this is the normally you are finding. In case, suppose like this example, KClO3 is converted into KCl plus O2. Okay. In this case, one atom undergoing, so this is plus 5 to minus 1. So it is undergoing reduction. So change in 6. And here oxidation state. Here minus 2 to 0. Okay. So change is 2, 3 atoms are there, 6. So here one element undergoing oxidation, one element undergoing reduction. In this case, valency factor is equal to anyone you can take with respect to chlorine or with respect to oxygen. The valency factor will be 6. In some other reactions, like you have equations like Cu to S is converting to Fe, S2 is converting to Fe2O3 and SO2. So in this case, here have plus 2 oxidation state, it has minus 1 oxidation state, here plus 3 and here plus 4. Okay. So change in here increase oxidation state, 1 increase. How many atoms? 1. So here 1. So this is take as the N1 is equal to 1. And second case, sulfur, minus 1 to plus 5. 5. How many atoms? 2. Okay. Here how many, what is the N2 value? 10. So it is oxidation, it is also oxidation. So in compound, 2 elements separately they are going oxidation only, either reduction only. In that case, we can use valency factor is equal to N1 plus N2. That is equal, we have 10 plus 1 is equal to 11. Or here N1 is equal to 1 plus 10 is equal to 11. So in this case, equivalent weight is equal to M by 11. We will come. Okay. And the next kind of reactions, disproportionation reactions will become. Disproportionation case like Cl minus, Cl2 is converted into Cl minus and ClO3 minus. So in this case, this is 0 to minus 1, this is plus 5. So this is change is 1, 2 atoms are there, 2. So this is the N1, and here 5, change is 5 and 2 atoms are there, 2. This is the N2. Okay. So N1 is equal to 2 and N2 will be 10. So in this case, how to find valency factor? is equal to N1 into N2 by N1 plus N2. So 20 by how much? 12. So 5 by 3. Like that we can able to find the disproportionation reactions balancing factor. Okay. So this is another type example we have. And one more important model, suppose they give like this equation 4Zn plus you have 10HNO3 giving rise to 4Zn NO3 twice plus you have NH4 NO3 plus you have water. So this is a balance equation is given. You have to find the valency factor or equivalent weight for this one. This type of reaction here 10 molecules are there, but here plus 5. Here some nitrates are plus 5. Here it is changing in oxidation state will be taking place here. Here you are getting -3 and you are getting plus 1. Okay. So in this type of reactions, how to find valency factor? In this case, how we can able to find either valency factor of into number of atoms of oxidizing agent equal to valency factor into number of atoms of reducing agent. Like that we can able to find. Here zinc converted to Zn2 plus. So plus 2 is a here zinc undergoing oxidation, so it is comes under reducing agent. So valency factor 2, how many atoms are there? 4. And here valency factor we have to find out number of atoms. Okay, how many atoms are there? 10. So from this valency factor is equal to 8 by 10. So 4 by 5. So you don't need to worry about that one. Just valency factor into number of atoms of oxidizing agent, valency factor into number of atoms of reducing agent formula we are using. Easily you can find when all the molecules are not involved in oxidation or reduction case. This is the finding and factor related. Next, finally, titrations. Titrations case only one rule will be there, that N1 V1 equal to N2 V2. It is one is related to oxidizing agent, another will be related to reducing agent. Same way, if you one is given in normality and value, one is given weight related means weight by equivalent weight. Okay, so it may be oxidizing agent or reducing agent. These titrations we are using, and here some other also we are using ideometry. So in this case, oxidizing agent will be I2. Okay, directly I2 we are using is oxidizing agent, then it is called as ideometry titrations. Ideometry titrations case, okay, substance react with some compound like potassium iodide and iodine will be produced. This iodine produced will be act as an oxidizing agent, then it is called as a iodometry titration. So directly we are using iodine as oxidizing agent, iodometry, and the compound produced, iodine produced in the reaction act as oxidizing agent, then it is called as the iodometry titrations. This is related to the redox reactions. Okay. Thank you.